All right, so we have been practicing with partial fraction decomposition, and all we've looked at until now is examples that had only linear factors in the denominator. They could be distinct linear factors or they could be repeated linear factors. This process becomes slightly more difficult if you have quadratic factors, so that's what we're going to look at today. If we have quadratic factors, then the top of our fraction becomes different. We'll set it up exactly the same way. So we're going to start with 2x cubed minus 4x minus 8 over, we have two different, well, I take that back. We can factor out an x from this one. So we're going to get x times x minus 1. So that's two linear factors. And then we have a quadratic factor in x squared plus 4. The linear factors, we've already seen what they do. So we're going to have a over x plus b over x minus 1. But then the quadratic factor has to have a linear numerator, like a linear function as its numerator. So we'll do cx plus d. It's kind of like the mx plus b form. Just keep going in the alphabet, whatever you've got. That is what's going to be over x squared plus 4. So it does make it just a little bit trickier. We're going to have to make more substitutions to be able to figure out what c and d as well as a and b are. But the process from this point now, it's just the setup that's different. The process is exactly the same. So we're going to multiply through by x minus 1, x squared plus 4. That leaves us with 2x cubed minus 4x minus 8 equals, x cancels out and we're left with a times x minus 1 times x squared plus 4 plus, this one's going to have everything but the x minus 1. And now we have plus cx plus d times, we're going to have the x and the x minus 1. Okay, so you can see quite a bit messier, but we're still just going to pick some convenient values for x. The quadratic factor makes it a little bit trickier to pick nice values for x because, for example, with x squared plus 4, there's no real number that's going to make that factor equal to 0. But let's start with the ones that we know are going to be pretty easy. I can start by letting x equal 1. That's going to cancel out the a and the whole last term with the cx plus d in it. So we get 2 times 1 cubed minus 4 times 1 minus 8 equals, the first term is going to cancel out. Then I'm going to get b times 1, so that's going to be b times 1 squared plus 4, so that's going to be 5b, and then the last term is also going to cancel out. So what do we have here? We have negative 10 equals 5b, so b equals negative 2. All right, we got 1 out of 4. Let's now let x equal 0. Because that's going to get rid of the b term, and again, that's going to get rid of the last term. So what do we get? 0 minus 8 equals a times negative 1 times 4. So this is going to be negative 4a, and all of the other terms, if x is 0, they cancel out because they're multiplied by x. So we get that a is equal to 2. Okay, so now we can go ahead and pick some values for x, but they're not going to be quite as helpful to us. So let's let x equal 2. I'm going to pick 2 because 2 minus 1 is 1. That's going to be an easy number to multiply by. So if I plug in 2, I get 2 times 2 cubed, so that's 2 times 8, which is 16, minus 8, that's going to work out nicely, equals a times 2 minus 1, times 4 plus 4. So this comes out to 8a plus, again, x is 2, so I'm going to get 16b plus 2c plus d times 2 times 2 minus 1, so that's just going to be times 2. Well, don't forget that we have also determined the values that we're going to use for a and b. So let's go ahead and make those substitutions. So we have 0 is equal to 8 times 2, so that's going to be 16, plus 16 times negative 2, so that's going to be minus 32, plus I'm going to distribute out this 2, 4c plus 2d. So I have negative 16, and if I add it to both sides, I get positive 16 equals 4c plus 2d. Well, that's great, but that is still two variables. And I can't just pick things for c and d. I can pick things for x. But c and d, we've got to use the values and the relationship that we're given. But if I picked another number for x and used what I know about a and b, I should end up with a second equation that also has the variables c and d. And then we can use a system of equations to come up with what we need. So I'm going to choose this time x equals -1 for no other reason than it is a small number. So go ahead and plug in what you get for -1. I'm going to come back here with my work in about 2 seconds. All right. The second equation that I have is 4 equals -2c plus 2d. So what we are going to do now is take this relationship and this relationship and create a system into variables. So I have 16 equals 4c plus 2d. You can see these quadratic ones are significantly more work, but none of this is algebra that we don't already know. Plus 2d. Now, if I go through and multiply the bottom equation by -1, now I can add them together and I get 12 equals 6c. These zero out. So I get that c is equal to 2. And now if we plug in for c, we get, I'm going to plug into that bottom one before I multiplied, I mean. So I get 4 equals -4 plus 2d, and that tells us that d is equal to 8. Nope, 2d is equal to 8, which means d is equal to 4. Okay, do we have it all? I believe that we do. A is equal to 2. B is equal to -2. C is equal to +2. And D is equal to 4. We have done it. Now we need to build our integral. Okay, so the integral now that we are working with is going to be the antiderivative of a over x, so that's going to be 2 over x, plus b, which is -2. So this will be plus -2 over x minus 1, plus, now here's where we get the cx plus d. C is 2, so this is going to be 2x plus 4 over x squared plus 4 dx. Okie dokie. Now, we need to go through and do this integral now. I will give you a warning. You are probably going to have to take the last answer, the last expression in that integral, and split it apart into 2 integrals. And I'll give you a hint. One of them should come out to an arctangent. So pause your video and see if you can follow through on this integral, because this is where it starts to get tricky. So pause and see if you can use some of these techniques we've been talking about. I'll come back with my work in 3 seconds. All right, first and foremost, this is how I chose to split this up. Now, you can do a lot of this part in your head, but I wanted you to see the 4 distinct integrals that I was going to evaluate. If you were stuck and that gives you a hint, pause the video now and see if you can finish it before I work it out the rest of the way. So here's what we get. 2 times the natural log of the absolute value of x, that's our first one, minus 2 times the natural log of the absolute value of x minus 1, plus this one we can use u substitution. If u is x squared plus 4, that means du is 2x dx. So this one actually works out to a pretty straightforward log rule. X squared plus 4. Now, you could take the absolute value bars off of that one because x squared plus 4 is always going to be positive. And then this one is going to be plus 4 times, it's going to be, I think, is it 1 over a? I got to double check. Yes, it's 1 over a. So that's going to be 1 over 2 arctan u over a, and that's all plus c. I'm going to rewrite this so it looks a little bit nicer. Your final answer is going to be 2 times the natural log of the absolute value of x minus 2 times the natural log of the absolute value of x minus 1 plus the natural log of x squared plus 4. Again, you can ditch the absolute value there. And then this is going to be plus 2 arctangent x over 2 plus c. And that is gross, but that's our answer. And that is most certainly an integral that we could not have evaluated any other way. So yes, it is tedious, but it is something that has to be done. And then here is the good news. On the AP exam, you do not have to be able to do quadratic factors. In this course, I expect you to be able to do quadratic factors. But on the AP exam, if you're worried about time, all partial fraction integration questions will use only non-repeating linear factors, okay? Again, for this course, we are going to be responsible for knowing more than that. But on the test, they only give you those in the interest of time. All right, we'll see you guys next time.